Today we'll be determining if the following series converges: the sum from 1 to infinity of 1 over n squared plus 1. And to start off, we could analyze the function f of x equals 1 over x squared plus 1. So we have to show that this function is continuous, positive, and decreasing. So we could say that f is continuous on the interval 1 to infinity. There's no discontinuity at all in this interval. F is also positive on this interval from 1 to infinity. So it doesn't matter what number you plug in between this interval, it'll still be positive. And now we have to show it's decreasing. So we take the first derivative. So we know f of x equals 1 over x squared plus 1. So df dx is 1 over g squared g f prime minus f g prime, where I'm going to be labeling this the top f and the bottom g. So df dx is equal to 1 over g squared, which is x squared plus 1 squared. G is going to be x squared plus 1. F prime, well, the derivative of 1 is 0. And minus f, which is 1. And g prime, the derivative of x squared plus 1 is just 2x. So we could see some cancellation here. We have negative 2x over x squared plus 1 squared. But this is clearly less than 0, so it's decreasing. So we have everything we need. So now we could perform the integral test. So our original sum went from 2 to infinity. I'm sorry, 1 from infinity. So the integral from 1 to infinity of 1 over x squared plus 1 dx. Now we just have to evaluate this integral. So this is an improper integral, so we could take the limit as b approaches infinity of the integral from 1 to b of 1 over x squared plus 1 dx. And that is a well-known integral. It's the arctangent of x. So this is equal to the limit as b approaches infinity of the arctangent of x, where I'm evaluating this from 1 to b. This is equal to the limit as b approaches infinity of the arctangent of b minus the arctangent of 1. So the limit as b approaches infinity of the arctangent of b, well, we could visualize this. So the arctangent function looks something like this. And here's an asymptote at pi over 2. Likewise here at negative pi over 2. So as b approaches infinity, it gets closer and closer to pi over 2. So this is equal to pi over 2. And the arctangent of 1 is pi over 4 minus pi over 4. So we could unify the denominator. We'll have 4 pi minus 2 pi over 8, which is equal to 2 pi over 8, which simplifies to pi over 4. So our integral actually converges. So then we'll say the following statement: if the integral from 1 to infinity of 1 over x squared plus 1 dx equals pi over 4, then we know that the sum from 1 to infinity of 1 over n squared plus 1 converges as well, because the integral converges as well. And that is the resolution when it's come up with, whether it's convergent or divergent. In this case, it's convergent. And that's it for this problem. Thank you very much for watching.